Hello class, this is the video for section Appendix A7, and it talks about complex numbers and solving quadratic equations in complex number system. Okay, the following are our learning objectives. We will do the operations of complex numbers, that is add, subtract, multiply, and divide, which sometimes we call rationalization. And we solve quadratic equations that the solutions is not a real number, but it's involving is in this complex number system. Okay, so first let's define what why we come across the complex number system, right? So for example, if we are solving equations like x squared, okay, x squared is equal to -1. We know that we take square root on both sides. Now we take square root of that, you have what? X is equal to plus or minus square root of -1. So the question is that this square root of -1, and this is not a real number, okay? It's not a real number. Therefore, that's why we have to extend the number system of a real number system to get what we call a complex number. And so what we're going to do is that we're going to denote, we call the imaginary unit. We're going to say I is equal to the square root of what? -1. And so for this equation, if I solve it, I have what? X is equal to plus or minus what? I. Okay. Where I is equal to the square root of what? -1. Okay. And so we will call the I an imaginary what? Unit. Okay. And when they square the I squared, when you square the I, what do you have? You have -1. Because if you have I is equal to square root of -1, and then I equal to square root of -1. Now, if you square both sides, you have what? I squared is equal to what? -1. Okay, later on, we'll look at powers. Okay, the powers of what? I. And then we'll talk, when we get there, we'll talk more about it. But for now, we are saying that the complex number or the imaginary number or imaginary unit is what? Is I is equal to square root of I, or the square of I is equal to what? -1. All right. Now, the complex numbers are of the form, okay, A plus what? BI, where A is A and B are real numbers, but A we call it the part, we call it the real part of this, and then the B is the imaginary part. Okay, so we have the real part, which is the A, and the imaginary part, which is what? Which is the B. All right, and of course, don't forget the I is the imaginary unit. So there are certain properties. First, we'll look at the what do you call it? The equality, the sum, and the difference of what? Complex numbers. Now, so here are the definitions. Okay, equality of complex numbers. If two complex numbers are equal, that A plus BI is equal to C plus DI, this is true if and only if A is equal to what? C, and then B is equal to what? Is equal to D, as we have here. Okay, now we'll take example. But if we are talking about the sum, since we have the real and the imaginary parts, we just combine like terms. Okay, so if I have A plus BI, then plus, that's a sum, C plus DI, then it's equal to what? A plus C, which is A plus, that's a real part of the complex number, and then plus B plus D times what? Times I. Okay, that is add real parts and the imaginary parts were separately. Okay, then we also have the difference, which is same complex number A plus BI. This time it is minus the difference. Then it's going to be equal to A minus C plus B minus what? Minus D. Because if you distribute the negative over the parentheses, the C will be, it will be minus C minus DI. And that's what we have there. So again, in this case, you subtract real parts and imaginary parts separately. Okay, we'll take examples now. So look at example 1. Say find the values of x and y if x plus 4i is equal to -3 plus what? yi. See, So if you have this means that if you compare them, okay, then see that x is equal to -3 and the y is equal to what? Is equal to 4. So this is true if and only if 3 is equal to -3, x is equal to -3, and then 4 is equal to what? Y, or y is equal to 4. So that is it. Very simple. And then we perform the operations indicated. Okay. We want to put the answer in the form. This is the standard form. Okay. This is what we call the standard form of what? Complex number. Okay. When it's form A plus what? BI. Okay. So exercise number 11, we want to write this down. Well, first, this could be, because it's plus, and it doesn't affect, this is basically a 2 plus what? 6, then plus -3 plus what? 8i. And that gives us what? 8 plus what? 5 what? I. Or we could remove the parentheses and combine like terms, just like I mentioned. This is be what? 2 minus 3i, and then you have what? 6 plus what? 8i. And that gives us 2 plus 6, and then minus 3i plus what? 8i. And that will give us the same thing, 8 plus what? 5 what? 5i, which is what we got there. Okay. So that is one way to look at it. Because if there is a difference, then of course, if you don't forget, the negative will affect what is in the parentheses. Okay, as we can see in exercise number 14. All right, so if I want to do this, okay, I have what? Imaginary part, and then what? The real part. So we can, all right, this is A, so this is minus minus, so then this is with 3, okay, 3 plus what? Plus 3, because negative will make that what? Make that positive. And then also we have what? Minus 4, and then minus times minus is positive, plus what? Plus 4. And so this gives us what? 6 plus what? 0 what? I, which is the same as what? 6. Okay. All right. So we want to talk about a conjugate, because before we can really talk about multiplication, right? Okay. So we talk about multiplication, we need to know what is called the conjugate of what? Of a complex number. All right. So which is the product. So the product of complex number, in this case, we FOIL it. Okay. We will, if you have A plus BI times AC plus what? DI. Now, if you FOIL it, you have what? A times C. All right. A times C. And then you have what? The B times D, that gives us this, and then plus AD, and then what? B plus what? BC. Okay, because if you have B, okay, BI, now look at it, BI times what? The DI will be what? BDI squared. And what is I? The I should definitely be what? Minus. So that's why we have this minus what? BD. That's why we have what? Minus BD there. Okay, so let's do the following. Okay, this is exercise number 19. I got negative what? 3i times 7 plus what? 6i. So this gives me minus 3i times 7 will be what? 21i. Then minus 3i times what? 6i will be minus what? 18i squared. Now don't forget, I squared is equal to negative 1. And so this becomes what? Minus 21i, then minus 18 minus 1, which will give me 21i plus what? 18. So put it in the form A plus BI, it is what? 18 minus 21i. Okay, you leave it like that. All right, let's go to the next one. Okay, if you want to FOIL this, all right, as we can see, depends on the sign there. So let's FOIL this. Okay, 5 times 2, that gives me 10. 5 times 2 is 10. And then 5 times minus 1i, which is minus 5i. And then 3 times 3i times 2, it is plus 6i. And then this time that is minus 3i squared. Okay, so let's simplify that. This gives us what? 10. And then 5 minus 5i plus 6i is what? Minus plus I. And then you have what? Minus 3 times minus 1. And that gives us what? 10 plus I plus what? Plus 3. Then the final answer will be what? 13 plus what? Plus I. 13 plus I. Okay? All right. Now, let's go to the conjugate. So we just talked about multiplying complex numbers, right? Now, let's talk about the conjugate, because sometimes we multiply a complex number by its conjugate. What do we mean by that? Okay, the conjugate, the conjugate of the complex number z equal to a plus bi is denoted by what? Dash. You put a dash of what? It's denoted by this. Now, which is the same as what? A plus bi, and then put a dash on top of that, bar on top of it. And it's equal to just the same, except that you change the sign to the opposite sign. So if it is positive, it becomes what? Negative. If it's negative, it becomes what? Positive. Okay, so let's take an example. So what is the conjugate of that? This is basically what? 3, and then have what? 2i. Then the sign between them changes, or the imaginary side, that's where it affects it, becomes what? Plus. So that is it. That's a conjugate. Okay. Another one, if you have minus 5 plus what? 3i, the conjugate of that, this would be what? The real part stayed the same, and the imaginary part changes sign. And so that'd be minus what? 3i. Okay. So now, if I have a complex number and I multiply by its conjugate, okay, what answer do I get? Okay, and then we'll write this and then generalize it. First, what is the z bar? That's the conjugate of that will be what? 3 plus what? 2i. Okay, so conjugate of the z given is that. So then let's multiply them. That is z times its what? Conjugate, which will give me what? 3 minus 2i times 3 plus what? 2i. Okay, we FOIL it. 3 times 3 is what? It is 9. And then 3 times 2i, it is plus what? 6i. And then minus 2i times 3 will be minus 6i. And then I have minus 4i what? I squared. Now, as you can see, this will be 9, okay, plus what? Plus 4. Because the I squared is what? Minus 1. Okay, so when you multiply this conjugate, you have what? 9 plus 4, which is what? Which is 13. Now, I want you to see this way. If you have 3, if I want to generalize it, 3 plus 2i minus 2i times 3 plus 2i. If you multiply this, it's just going to be what? The 3 squared plus what? The b, in this case, which is 2 squared. That's why you get 9 plus 4, and that is what? 13. Okay, so generally, if I multiply a complex number by its conjugate, like a plus what? Bi times a minus bi, you get what? A squared plus b squared. Okay, a squared plus b squared. That is the product of a complex number and its what? Conjugate is a non-negative what? Real number. Okay, very, very important, because when we get to dividing or rationalize complex numbers, it is, if you don't know this, that's makes life quicker and easier for you. Okay. Now, it says write each of the following in a standard form. The following in the standard form. So we have 2 minus I divided by 2I. Okay, this is what we call the process we're going to do is what we call rationalization. Okay, rationalization. So that means that you multiply, this tells me multiply the top and multiply the top and the bottom by the conjugate of the bottom. Conjugate of the bottom. So that means that you multiply the numerator and the denominator by the what? The conjugate of the denominator. So what we have there, we have what? 2 minus I over 2I. Okay, the conjugate of 2I is what? Minus 2I divided by negative 2I. Okay, and then when you have this will be 2 minus I, the times what? Minus the 2I divided by what? The denominator will just be what? To 2 squared. Okay, because you have 4I squared and negative 4I squared and a negative, so I squared is negative, so that makes it positive. So what we have there would basically, let's distribute that, that would be minus 4I and then plus what? 2I divided by 4. And then we are writing in the form, so that becomes what is equal to minus 4 over 4, then plus what? 2 over 4I. And that it gives us what? Minus 1 plus what? 1/2 I. And that is in the form A plus BI. Okay, now let's look at a second one. We're going to rationalize this. So what do we do again? For rationalization, what do? We multiply the top, okay? Multiply the top and the bottom by the conjugate of the bottom. All right, or multiply the numerator and the denominator by the conjugate of the denominator. So what's the conjugate of what? 1 plus what? I. It is 1 minus what? 1 minus I. So you're going to divide 1 minus what? I. Okay, so the numerator becomes 2 minus 3I and then 1 minus I divided by, when you multiply this by that, it is what? It's going to be 1 squared, then plus what? That 1 squared. Because I is 1I, but because we don't write the 1 there. All right, so what does this? This becomes just what? Get 2 times that. So that'll be 2. 2 minus what? 2I minus 3I and then plus 3I squared. Okay, divided by what? Divided by 2. And that gives us 3I squared is same as minus 3. So that is what? 2 minus 3. And then I have minus what? 5I all divided by what? 2. So that gives us minus 1/2 and then minus 5 over what? 2I. And that's my answer. It's in the form A plus what? BI. Okay. All right. Now let's talk about the powers of I. Okay. We know that if you raise it is I, okay, I squared is equal to minus 1. Then I cube, all right, we write it as what? I squared times I, and I squared is negative 1. So that gives us what? Negative I to the 4, we split it into what? I squared times I squared. And the I squared is negative 1. So negative 1 times negative 1 is what? It is what? Positive 1. Okay. Similarly, I to the 5th, you get negative 1. I to the 6th is what? Negative 1. Positive I, and a negative 1. I to the 7 is what? Negative I. And then you have what? I to the 4. 8 is what is that. So do you see a pattern? Okay. Look at the odd, I cube, okay, I to the 5th, I to the 7th. All right. So you see that I to the 3rd is the same as what I to the 7th. Okay. And the I to the 4th is 1, is the same as what? So if you have multiples of 4, okay, multiples of 4, any number raised to, which is a multiple of 4, it becomes what? It becomes 1. Okay. All right. So let's use this to evaluate the following. Now, if I have I raised to negative 15, this is the same as 1 over what? I raised to what? 15. Okay. Now, notice that if I have I to the 15, it's the same as I to the 5th or to the 3rd. Okay. So let's evaluate that. What is I to the 5th? I to the 5th is what? I, which we write it as what? I to the 4th times what? If you cannot see it from there. So then that becomes what? That becomes I to the 3rd. And what is I to the 3rd? You guess what? It's negative 1. Okay, as we can see here. Or if you I to the 3rd, if you don't remember, then you can see write it as I squared times what? Times I. And I squared is what? I squared is negative 1. So that gives me what? Negative I. Okay. So what we have there is basically what? 1 over what? That gives me 1 over negative I. Now, since I is in the denominator, we have to rationalize. So we're going to multiply by what? By I, and divide by what? Divided by I. So the numerator is what? I. You get I divided by, that's minus what? I squared. Okay, minus I squared, which is what? I divided by minus 1. Okay. So you have what? I squared, negative of that is, will give us what? So that gives us, that is negative. So we multiply that, it's going to be, what do you call it? That will be just going to be what? Just going to be I. Okay. So let's check that and make sure we have negative I. All right. So we rationalize this. We multiply the numerator by I and divide by I. And then we have negative I times I is negative I squared. All right. As we can see there. And then what is I squared is negative 1. So that makes it positive. So we get this answer. All right. Let's look at the next one. I raised to 100 and what? 101. Okay. Now notice that is the same as I to the 100 times what? Times I raised to 1. But I raised to 100, okay, is the same as a multiple of 4. So I will write that I to the 4 raised to what? 25, because 4 times 25 is 100, then times what? Times I. Now what is I raised to 4? It's what? It is 1. So 1 raised to what? 25 times I. So that gives me just what? Just I. Okay. And then we go to the next one that you're going to multiply this. You have what? 2I squared times 1 plus I squared. Okay. So if you distribute, that gives me 2I squared plus what? 2I raised to the 4. Okay. So that gives me 2I squared. Okay. Plus what? 2 times 1. But what is I squared? Okay. You get 2 minus 1 and then 2 times 1. And that gives you what? 0. All right. Then finally, solving quadratic equations in the complex numbers system, in complex numbers. Okay. So we're going to solve each of the following. So you have x squared is equal to negative 9. we want to solve, we take what? Take square root on both sides. Okay, take square root on both sides. So that gives us what? X is equal to plus or minus square root of what? -9. Now notice that this is the same as plus or minus the square root of 9 times the square root of -1. So that is where we introduce the what? The I. Okay, this is the main bulk of what we have done today. And this is solving quadratic equations that you cannot factor, is not a real number, but it's a complex number. So the answer is that, okay, square root of 9 is positive 3. So the plus or minus 3. And then square root of -1 is what? It is I. So that's the answer. So your solution is what? The set is going to be minus 3i, comma, positive 3i. Okay? And then we'll look at the second example, and that will be the last for this video. Okay? You have x squared minus 6x is equal to -10. Now, this is quadratic, so we need to move this to the other side. So this equation becomes what? X squared minus 6x plus 10 equal to what? 0. Now, if you want to, you can factor this. You can use the factor. So you have to use the quadratic formula. Okay. So to solve this, we use the quadratic formula, which is x is equal to, minus b plus or minus the square root of what? The b squared minus 4ac, all divided by what? 2a. Okay, so in this case, what is my x? What is my b? My b is minus -6 plus or minus the square root of the -6 all squared. See that I put that in parentheses. Minus 4 times a is 1, and then c is what? Is 10. Okay, then everything there divided by what? 2 times what? 2 times 1. Okay, everything is divided by 2 times 1. All right. So we have, okay, so what would that give me? This is equal to, it'll be positive 6 plus or minus the square root of what? 36 minus what? 40 divided by what? Divided by 2, which will give us 6 plus or minus the square root of what? -4 divided by what? Divided by 2. But what is that? This is equal to 6 plus or minus, that will be 2i. Okay, divided by what? Divided by 2. So the answer to that will be what? 3, okay, plus or minus what? I. So what's your solution? Solution is that it's going to be this. Okay, it's going to be 3, okay, minus I, and then 3 plus what? Plus I. Okay, and that'll be your answer. All right, so with that, we come to the end of this video, and I'll see you in a bit. Bye-bye.